With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Let E1 and E2 denotes the gravitational field at a distance R1 and R2 from the axis of infinitely long cylindrical wire of radius R. Which of the following holds true? So if I make the side view of the cylinder, let's say this is the cylinder and this is infinite, and if I make a Gaussian surface to calculate the electric field inside at any inside point and any outside point. So for inside point, let's say I draw this, right? So here this is the axis, right? So if you see this distance is small r and this distance is capital R. So if you see here from the symmetry, since it is an infinite cylinder, this. So if you apply the Gauss law, I will write down. So this will be the Gauss law for gravitation, right? Here we write down the gravitational flux will be equals to the enclosed mass by epsilon naught, right? Net flux, that is equals to closed integral of E dot ds, is equals to mass enclosed by epsilon naught. Here Q is the mass enclosed, right? So let us see, if I see the E dot ds for this volume that we selected here, at this surface and at this surface, the electric field and area vector will be perpendicular, since the area vector will be directed along the axis, and electric field, you know already, it is directed radially outward like this. So let's calculate the electric flux, the E dot ds for this curved surface, right? If you see, let's say the length of this Gaussian surface is L. It is L. So if I write down the area of this, it will be equals to, if you see this is length L, and if I write down the area of this, it will be 2 pi r, this is the width into length. This will be the area of this surface, and through each point the electric field will be directed radially outward and it will be along the area vector only. If you see at any point the area vector and this electric field vector will be parallel to each other, so you can write down it is equals to charge enclosed. If I write down, it will be charge density times volume. So volume will be same. If you see the cross section area, it will be pi r square into the length by this, right? So this will be the final equation. So you can cancel out this pi and L and L, right? You can see the relation between the E and the R, right? So if you see for any point which is inside R less than R or equal to R also, E will be equals to, this R will get cancelled out, right? This R, small r will get cancelled out and you will write by 2 epsilon naught. So it is directly proportional to R. If you see the option, if R1 is less than R, so both are less than R. So we know that if both are, if R is inside, field will be proportional to R. So if R1 is less than R2, E1 will be also less than E2. So this statement is the correct one, right? Now both are outside point. If you see the second statement, it is said that both are the outside point. Both are more than R. Now let's see what will happen. For outside point, if you see here, the Q enclosed will become fixed. This quantity will become fixed. How? If I write down the Gaussian surface, it will be the same, but the charge enclosed will be this. This R and this R will not be same because the charge is not there after R more than capital R. Charge is not there, right? So here we have to put the value of small r equals to capital R. So now you can see here this pi and L will again get cancelled out, right? So this calculation we are doing for R greater than R, right? So pi and this will get cancelled out, and you will write pi got cancelled. So I will write down rho R square by 2R epsilon naught. So it is inversely proportional to R, right? If you see, it is inversely related with the distance from the axis. So if you see here, if R1 is less than R2, then E1 will be more than this. So basically, we know that for outside point, it is inversely related. So this option is also correct. For the B, this relation. For the A, this relation. Inside point directly proportional, outside point inversely proportional. Moving ahead, if you see the next option, it is said that the R1 is equals to R minus C and R2 is R plus C, where E is positive, then E1 is more than E2. So if I write down, so basically for inside point we use this formula, for outside point we use this formula, right? So now it is said that the R1 is R minus E, R2 is R plus E. Put here, I will write down the E1 is equals to E2 is equals to, I will put the value of R as this, 2 epsilon naught, it will be R plus C. Now you can compare the two, right? Basically rho by 2 epsilon naught is same for the two, but to compare the rest we have to a bit solve it. I will write down E2 is equals to rho by 2 epsilon naught. Here I will do what? I will subtract E square and add E square. So if you see, it will be R minus E plus E square by R plus C. Right? So you can see very clearly that this, if you take this rho by 2 epsilon naught inside, this is nothing but the E1 only. So we added something to E1, right? We added something to E1. So E2 is equals to E1, this is E1 only, you can verify from here, plus E square by E plus R. So here E2 is more, right? So if you see here, C will be incorrect, E2 will be more here. So A and B are the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.